So we were here like Docker engine part. So host OS is just used for running the Docker engine, and then all other part Docker engine will manage. So the operating system of this container as well, Docker engine will manage. Okay, let me clear this. So how it works? We have one OS. Okay, we will have one OS, whatever it is. Linux. Let's suppose it as Linux. Inside that, our Docker engine will run. Over that, our Docker engine is running, and then inside which we can have as many as containers. We can have application running over container for Windows machine. Only CLI. Okay, this is for app container Red Hat. This is for app for CentOS. Okay, we can use app any with basic Alpine. These all are OS what are defining here. Okay, so these are operating systems. So this is how Docker engine usually works. Okay, so are you clear with Docker image thing, like what Docker image is, or not yet?
Can you please explain once again about the image, brother? Docker image.
Docker image.
Yes, brother.
Okay. So Docker image is basically a package. Okay. Package of what? Package of operating system,
OS.
OS, application code. Package is required for application code. Like running application code. Okay. So let's suppose you have application code in Python. Okay.
Hmm?
So one thing is like let's suppose you are using Linux operating system here. Okay, I'm not going to using the Python operating system here. Like basically this OS means, let me make it clear, this means some image. Okay, OS image. So this OS image could be of Linux. We saw yesterday, like we have one two images
Hmm.
there. So what we have to do, we have to import the image. We have to import the image there. So let's suppose you
Hmm.
imported Linux. Now you have app code written in Python. Now you need Python 3 or whatever Python you need. You need those packages, right? Paper.
Yes, brother.
Let's suppose
Hmm.
you have TensorFlow required. So you will need these all packages, okay? So these packages are defined here. Package. You will have a set of commands provided here which will install all these packages. So it is like image is like you bought a new computer, new PC, okay? Now you installed one OS there, Linux. Now you have to run a Python code. Someone provided you Python app code, okay? They tell you that you have to install Python 3 on your PC, TensorFlow, Keras, anything. Okay, so you installed these. So if you have new PC, how will you install? You will install it manually, right? You will go to browser, you will download Python, you will
Hmm.
download these all packages, right?
Yes, brother.
But in Docker image, you have to do it via set of commands.
Okay.
Now you have to find these commands. So let's suppose you pull Linux. So what you can do, you can use apt package manager. So as we discussed earlier, we have one package manager named apt in Python in Ubuntu. We have yum in CentOS. Okay. So we have these apk is the package manager for Alpine. So what you have to do, you have to use those commands to set up the package inside that. So every time you are writing a Docker image file, you just have to think of it as of a like a new machine. You set up, you write first line. First line is from Linux, from Ubuntu colon latest. Once you write this command, what in your mind it should be like you have new machine now. Second part is copy the code. Copy dot dot means from the current directory copy to image. Now run command. Like these commands I will explain more in detail. So you have to run apt install python 3. Once you run this apt install python 3, it means your machine, the machine you just start creating, the container which you just start creating here, have python in now. Okay, earlier it wouldn't have python, but now it have python. You would need some other command, some other package as well. Run apt install any other package, whatever you need. Okay, now another run. You can merge these runs as well, but we will go on optimizing that slowly. So this is the example of docker file. This is the example of docker file which is used to create a docker image. Okay, so you provided operating system name, that is form of image. You provided the code, you defined the steps to install the packages. Now in last you will define what is the command to execute your code. You would provide the command to build your code as well here. So build first and then execute. So till build, once you build the image, okay, till build it will execute and store it in the form of package. Okay, now that package, when you run that docker run command, what it will do, it will run execute this command. So I just mentioned till this build. See, once you run this docker build command, it will execute all commands till this build and a but form a docker image that will contain everything. Even this execute, like, will execute command layer, but this cmd. So one command is there, cmd, which got ran at this runtime. When you do docker run, it will run the command defined here. So uh, let me open a new one. So you write, okay, let me show you example of docker file only. Okay, so if you see here, are you able to see my screen?
Yes, sir, I am.
If you see here, from, okay, so it is pulling some operating system. Operating system means image. So one thing, I was talking about operating system, but you can see this is not the operating system. This is some application, right? So what does that mean is, it is some image that will have some operating system. So if I go to Docker Hub, node 16 image, this is Alpine. Let's go back to node official image. Let's go to node 18. Okay, 18 is there. If you go there, you see it, this is the docker file. So if you use node 18 inside your docker file, it means this is some image. This node 16 is node 18 is some image. What that image is, this is that image. And every image have its docker file. So if you go there, it has its docker file node 18. Okay, now from build pack dabs dot colon bookworm, it is also using some docker file. Okay, docker image. So this is some other docker image. If you want to know what operating system it is using, you can keep tracking it to the bottom, because build pack dabs, if you go there, so it was latest, right? Bookworm, bookworm. If you see here, now it is using this tabs bookworm scm, bookworm scm. It is using bookworm turl, bookworm curl. It is using Debian. So finally, you are at the bottom, and you know, okay, so my image operating system will be Debian. Okay, that is the Linux flavor. So if I go back here, I have, see, you can use this as an operating system now. Why? Because node 16 is an image. In the base, it is an Debian operating system. So if you install this node 16, what it will contain? It will contain all these details, all these packages which are defined there, then those are defined there. Okay, because it keep extending. So initially these packages got installed, then one image got created. Inside that image, these packages will be there, these all others will get added. Okay, apt get, apt install. After that, these all will get added. Okay, and after that, this is getting added. So if you see here, these all are here, and there will be a command to install the node as well. Okay, so if you see there, these are the commands to install the node finally. So is in this package you have node, then you define, like we define working directory. I will show this practically what this means. So this is the working directory of image. Now here it starts copying the code. So package JSON, so this is for node. It define what all packages are there which are required for my application. So it is copying it, it is copying one other file of packages. Now it is installing those packages. Okay, so installing those packages where? Inside the image. Now copying my main code, copy main.js dot star means dot. After that, it provide these entry points. So entry point and cmd is the command which ran at the time of docker run, not the time of docker build. So it is, this is how it works. So do you have any idea, or it looks clear to you?
That is clear.
So docker image concept looks good to you, or you have some doubts?
Yeah, it looks good, brother.
Even if you have one doubt in your mind, just let me know, because this is the part, this docker image, this docker container is the part in which I want you to be the expert. Because once you have docker image knowledge, then container knowledge, then you can easily grab that Kubernetes part, and then you will be able to do this Docker Kubernetes, managing the application over them easily. So if even you have one thing, one doubt, then let me know. Okay, so
Sure.
once you create this image, okay, this image is created, it is stored anywhere. It it will be stored firstly on your local. You can push it to Docker Hub. you can push it to ECR, you can push it to ACR, you can push it to JFrog, Artifactory, you can push it to GCR or any other, okay? So you can push it to anywhere. So this is currently static. Now to run it, it is once you run that docker build, wherever you run this command docker build, docker image will get created at that machine, okay? Once that image is there, you can run docker run. Once you run that docker run command, what it will do, it will form a container, okay? Container, what container is? Container is the executed for executable form of this docker image. So image is static while container is dynamic, okay? Container has some life. It is static, which is placed somewhere. You can keep it stable for years, that doesn't matter. But container, once container is running, it become accessible. Everything happens after that only, okay? So what I want from you is to understand in depth what image is, then why, like how to create a container or how to use a container, and then you would be good, okay? We would be good to go ahead. So container is so docker is a technology, you can say. Yeah, docker is a technology while container is a concept. So docker can use it, containers, Kubernetes can use it. In Kubernetes also we have containers, in docker we have containers as well. But docker is the most basic concept which came in picture. That's why I'm focusing on docker first, then we will go to Kubernetes. So K8s or Kubernetes, okay, which is one of the most limelight topic which you need to learn, okay? So
Kubernetes, sir.
I sorry.
Kubernetes.
Yes, Kubernetes. I hope you are clear with this Docker image part, right?
Yes, sir. Mm.
Okay. Uh, okay. Let me show you how to build an image as well now, so that you can, sorry, so that you will have idea how Docker works. Okay, how Docker image looks like. So mkdir docker text, I'm creating. So here what I'm going to do, I'm going to pull a node hello world, okay? Node hello world, okay? So this is some file which I'm going to use. I have cloned that code. So this is my code, okay? Basically this is what, this is my code which I will run to, which like uh, which for which I will create a docker image, and then I will show you how it works. So first of all, what I should do to create an image, tell me.
So we need to like fix the OS and then after packages.
See, for that, for all these files, this is not like you will create a command by running OS.
Mm.
What you have to do, you have to create a docker file, okay? Inside that you will define everything, and docker file should be in the same directory. Like, it is best to keep it in the same directory where your code is, okay? Nano docker file, what first command should be? From node, I'm taking node 18 again, okay? I can see like this is okay, node 18. I'm taking node 18 only. Now work dir. So purpose of work dir is where should my code get pushed inside Docker image. Okay, so don't think it of as a machine from here where you are running. It is where that Docker image will keep the code. So I'm putting it as slash app slash Krishna. So the code will be there inside app slash Krishna. Okay. Now copy copy command is for copying the code from your current directory to the to this directory. If you don't provide the path to this directory inside your Docker image. So what I'm doing, package, the file name was package.json space dot. For next, what I'm going to do, I'm copying this second file. Okay, at last I will be copying index.js dot. So there are two ways. One way is either you can copy whole code there. One way is to copy the needed files. Okay, needful files only. So best approach is to just copy the needful files. But if you need all, you can simply type. If I would have typed copy dot dot in the first line only, then I won't have to use these two other lines. But in that case, it would have copied this dot vs code, dot git ignore, pretty rc, readme as well. Okay, now it is just copying these three. Now what I have to do, this is for running the container. Again, cmd is for running the container, not for image, but we have to define it while running the while building the image. Okay, so I am doing cmd npm start, saving this file. Now when I do docker, so this is one of the limitation of docker, that it needs super user permissions. Okay, super user permissions to run it. Sudo docker build hyphen t. Hyphen t is for tag. What is the name of our image? Like what should be the tag of our image or name of our image? So I'm giving as Krishna test space. What is the path of my docker file? So where I created my docker file in the current directory. So I can provide a dot. If I would have some other name than this docker file, then I would have provided dot slash docker file name. Okay, but currently I'm using, this is the like common notation which needs to use. So if you are using this, then it is well and good. If you have to provide some other name, then you have to give that name here. If your docker file is in some other path, then you have to give that path here as well. Okay, I'm running this command as I'm super user here. I have to run it as super user, so I would need to provide that password of my machine and then simply run it. I ran that. Okay, so if you see it, that image build is in progress. Okay, initial step, what it does, from docker library this node, so it is pulling that node image from where, from docker hub to where, to my machine where it is building this docker image. Okay, so it will take little time because that node 18 is big in size, so it is like these much layers are there. So just a moment. So if you see that docker image is built successfully. Okay, now let me walk you through what is here. So it is starting building the docker file. Okay, here it pulls the image which I defined at the top from docker io build library, whatever it is. Okay, now these all are the layers there. What all these layers are? These all the layers which are again defined in the Docker file. So this is the Docker file for node 18. So all these commands, okay, if you see arc and these, so these commands will run on not this. Okay, yeah, this is one. So these all commands, so these all create images, and inside that image it will have those like layers. So if I go to tags and search for 18 here, it has set of these all tags. Okay, 18 only. Which one was that? 18 only, right? So node 18, 18 slim, 18 slim. So even if you see in these all, so these all have layers, these much layer, 1, 2, 3, 4, 5. Okay, so these all layers were there. Okay, it pulled those. Then in the second command, it made that work dir slash app slash kirsna, copied the packagation, package log, copied the index.js, exporting to image, exporting layers, and then writing image. So it created this image, naming the image to this Krishna. Leave about this docker io slash library. So this is the actual name of your application, that is of your image, that is Krishna hyphen test. Now if I do docker images, I will be able to see this image, Krishna test. Okay, this is the image, this is the repository, this is the tag, basically latest or some version. If you want to provide version, then you can provide while building the image Krishna test colon and then the version. Okay, but let me show you again how to provide that version. Now again it won't take too much time because those all layers are already built. So it can pull it from the cache. If I run it docker build hyphen t Krishna test colon 4, it won't take that much time. It create it, if you see, it is, it pull them from the caching, cached. Okay, now if I do docker images, I have two images. One is Krishna test 4, another is Krishna test latest. Okay,
Latest.
so these all are the images. Now this is the image id basically. So if you see image id is same, why? Because there was no difference, there was no hash difference in between the images created, like when it was created. And what is the size of image? Lesser the size, good the image, but sometime it keep increasing as well because of application requirement. But in our case, this shouldn't be this much. But as of now, I'm giving you example, that's why it is fine. Otherwise, we can use one alpine image. Using that, we can reduce it to even 50 MB as well, 50 or 100 MB max. Okay, but now being we have this image, see, don't think that you can see this image now anywhere else. This is the image, this is packaged somewhere by docker in the form of these layers, and you can't do anything now. Now what you can do only is you can run this image, or you can store this image somewhere. You can either store it somewhere, run it, well, like both are parallel. You can store it somewhere so that someone else can use it as well, or for your purpose, for your usage later on, you can store it somewhere and you can run it. So once I let me run it, sudo docker run hyphen t, let's hyphen p, p is for providing the port. Okay, so we have to run it on some port. So if you see here, it is running, it will run on port 3000. So I have to define on what port it will run inside the container, and it will get exposed on my machine. So now there will be two things. One is application running on my machine, okay, this machine. One application running on Docker container which is running inside my machine. So as I mentioned, Docker container is completely isolated from my machine. Even though it is running inside that machine, it is isolated. So if you see this hyphen p, so this last p, this is the port over which our container is running. So what we have to tell here is my application will be running on this port inside the container 3000, and on my machine where I am using this container on like this Docker engine, it should get exposed on this port. You understood this or not?
No, brother.
No, right? Okay. I will be running the container.
Hmm.
Let me first run the container without exposing this port. Okay. Sudo docker run. Then I have to provide the image name. I am providing this one so that I don't provide. Sudo docker run. I ran this. What it will do? It will run my image. Okay. It will run my basically the application. So if you see server running on this localhost this, what does that mean? If I go in my local and copy this, it should run, but it is not running. Why? Because here this I'm doing on my machine. Okay, this localhost 3000 where I did it on my machine. But where is this app server running? Where is this server running? It is running inside the container. So if you see, if I do docker ps, container is running now. These names are provided by default. If you don't provide the name, you can provide the name by providing hyphen n flag in this, but let's leave the naming part. It is not that big thing is you have the container running. These are the logs of your container. Your container is isolated from operating system, from your machine. That's why when I'm doing this localhost 3000, I'm not able to access it. Okay. Now what I have to do? I have to stop it. So what we can do, docker stop and the container ID. This is the command to stop the Docker container. Once I run this, it will get stopped. Let it be. Okay, it is stopped. Now to remove the container, we can run this to even remove it from the stop state. Now here, if don't get confused with these tabs, like I have opened one here, one there. These are basically same terminals. I just shown it so that in one terminal you will be able to see these logs. You will be able to see these logs, and another terminal you will be able to see this container. Why? Because once these logs are visible here, you can't run any command. Okay, we will see how to overcome this, but at moment if your application logs are visible here, you can't do anything. So once you do that docker run command, you have to provide the ports. Hyphen p is the flag 3000 3000. Now tell me one thing, are you aware about that thing that if any application is running in your system, it will run on any of the port. It will consume your port, networking port. Are you aware about that or not? Hello?
No, brother. I am not aware of that.
Okay. So if so see, you have like we have a lot of ports there. Let's discuss that one. So range of ports is from 0 to 65536. Oh, sorry, 65535. 536 or 535. 535. Okay. out of these ports, okay, this is kind of port. So well known port are 0 to 11, 0 to 1023. So these are the ports commonly used. Okay, so 22 port is for SSH, port 80 is for HTTP connections, port 443 is for HTTPS connections, 5432 is there, that is for PostgreSQL database. So these all are the things. Okay, so if any application is running, it will consume your computer system port such that your computer will know, okay, that if someone else is going to run something on that specific port, it will know that something is running here and I can't run that at that same place. Okay, so this is the purpose of ports. Okay, these are Unix basically. So you got little idea or not? Let me say purpose of. See, this is one of the other point. So if your five applications are running on your machine, okay. So how will machine know to where it needs to send the traffic or where to send the request? For that, it use for allowing to connect to other devices and for sending the requests. Okay, so if your application is running on port 3000, yeah, if you are running this code, how will you be able to access? Because you need to tell the machine the address of the whole system, whole place where it is hosted, where it is running. For that purpose these ports are used. Okay, you got the idea now little bit.
Yes, brother, I did.
Okay, so this is the 3000 port where inside your container where it is running at 3000 port. Now this is for container, not for your machine. You have to define the port here as well on your machine where it will run. So it is kind of port mapping. So you mapped it like 3000, 3000, and you took Krishna test. Let me define password. Once I run it, now I will be able to access that localhost 3000. You see, my application is running now. Hello node. Okay. Now here 3000, and inside my container it is running at 3000 as well. So let me show you. Uh, this is my running container. Okay, here it is showing port 3000, 3000. Let me go inside the container. So you can go inside the container using how? Going inside the container means currently these all commands, whatever these commands, I'm running where? On my machine. But once I run this command, docker exec it this, I will exist inside whatever command I will run. I will do it that work inside that docker container. So if I do press enter, you see hashtag there. It means now I'm inside another CLI. So if I do who am I root, okay, if I want to see users there, so these all are the users, daemon, these all users are there. Okay, node there. Okay, if I do ls, so these all are the files, these were the files which I copied, you remember? Inside that copy part I copied these all files only, index, package log, package.json. So I just copied these, so these are there. If I do pwd, that is for present working directory, where I am inside app Krishna. Okay, what is my port running, over what port my application is running? Okay, lsof command is not there. If I do apt, I can install the packages there now. But whatever package I install there now, those are for my own testing purpose. For running the application, we need to package define the packages at build time. Okay, when we are building the image. So I am installing lsOS. Now I'm running. I would have provided you that command in the networking section. If you see node is running, what port? 3000 port. It is listening on
2000.
3000. Now to go out of, so see, now where I'm inside the container. Now I want to go to back to my machine. What I can do, if you see, if I run docker command here, it won't run. Why? Because I'm inside container and here docker doesn't exist. The docker CLI doesn't exist. But if I do exit, now I'm again inside this Sumit, inside back our machine. If I do pwd, then see here I'm different directory. Now it is my machine. Okay. Now one more thing I want to show that related to that. Okay. So here if you see, we are getting the logs here. Now you could ask like, why I'm seeing these logs here? I don't want to see my logs here. Okay. So for what we can do, we can first close this. Uh, See, I'm doing this control C. Don't get confused. Like
Control.
he, don't see like I'm doing control C, but don't get confused that he's first doing control C and then doing sudo stop container. So I'm trying to first stop it via control C. If it is not stopping, okay, then I'm going to run this
Okay.
sudo stop, sudo docker stop. Sorry. Once my container is stopped from here, you will stop seeing these logs as well. Okay, my container is stopped now. Now what I'm going to do here, I'm going to add one flag, one more flag, that is -d. -d is for detached. Detached means it won't show these logs and other things. In background, it will keep running. So the risk of running command like this is without -d's. If your machine get stopped, okay, your container can get stopped as well. Okay, so let's suppose you are running on some virtual machine, some EC2 machine, Docker. Those machines will remain up and running, you remember, right? Even though you disconnect from it, it will keep up and running 24 into 7, 24 by 7, right? So your container will be up and running and you can access those applications similar to this. Here I am doing with localhost. There you can access it with your IP or domains similarly, right? These websites similarly, like similar to these websites, if it is hosted on Docker. But now if I do -d here, it will keep running in the background. If you see, it will provide me a hash here. It just provided me the hash and it exited. Okay, if you see. But if I do sudo docker ps, you see, container is up and running. If I go there, if I do this, container is up and running, right? So this is how applications are hosted. So if you compare it with something running on your EC2 machine, so this is my laptop. Okay, currently this Docker is running on my laptop. If I turn off my laptop, this container Docker engine will stop definitely, right? Docker engine will stop. Docker engine will stop. Then this container will stop as well. And the container will stop. This website will stop working. But in the case if Docker engine is running and container will keep running. Okay. So if it is on EC2 machine, some EC2 machine, which will keep running 24 by 7, you ran that container there in this detached mode. Even though if you see, if you run it in this form, you need to keep your CLI open. If you need to keep connected to the machine. But even though if you run it in detached mode, then you don't need to be connected. Why it is running in background now? Okay, so if you see, so this is how applications work. If you are hosting some application, let's suppose you created some website like your application and you want to run it permanently. What you can do, you can run a container. What you can do, you can run a container and attach that IP address, like public IP of your EC2 machine, to some domain and use that. Okay, there are like lot of problems with running the problem directly inside container as well, because what if it gets stopped automatically due to any error or other things. For that purpose we will discuss Kubernetes later on, but yeah, for now this was for Docker part. Okay, now if this concept as well, if you want, like inside application it is running on 3000, but here I want to run it on 4000, you would have one question, right? On your machine, on your local, something is already running on 3000, yeah, then you can update this. What you can do, you can first stop the container. Here as well, if you see mode as joy alert, you can copy this name, paste it. I will give the name as well this time. Till now you are getting these random names, okay? Elated, Rubin, these things. But after this time, I will show you two things. One is to provide the name, hyphen n or hyphen hyphen name is there. Uh, Krishna container. And there I'm going to run it on 3600 3067. I ran it. If I do docker ps -a. Okay, sorry, I think I need to provide hyphen hyphen name there. Let me check. Okay, so this is the container which is exiting every time and it is not getting that name. We can see error if possible, kubectl, oh sorry, docker logs, and then the container name. Okay, hyphen hyphen name is not available, that is bad option. So in that case, it needs to be provided before the image, so image should get passed in last. So Krishna container. So this is how you can debug the things. That's why I'm putting these names here at different places. So if your container couldn't run successfully, what you can do, either with container id or with container name, you can run this command docker logs. With docker logs you can see the application logs, and application logs you will get this. Okay, so basically in last, what it does mean, after this image name you need to provide what, you need to provide the arguments for calling, like some command which it can run. Okay, hyphen n is not supported as well, it currently directly throw the error, so hyphen hyphen name could be there. Okay, so this is the command now as it is taking, so it means it is going to be successful. So if I do sudo docker ps, you see name is Krishna container, where it is running inside the container, it is running on 3000 port. We can't change this port. Developers will guide us how to update that port, then only we can update. In this case we have to pass this environment variable named port, then only we can update that internal port. But by default it is running on 3000, so we can't change that. If you make it 3000, if you make it 3067, your application won't work. Why? Because how traffic is routing there is, you are on your machine, on your local, it is when you hit 3067, inside container it will hit on 3000 and then it will respond. So if I do 3000 now, it won't work. Why? Because on my machine it is pointing to 3067. So if you see on 3067 it is pointing to that application. Now I ran it in detached mode, different port, and hyphen hyphen name. So make sure you provide hyphen hyphen name before the image name. In last you have to provide the image name. After image name you can provide the command. Okay, command like that you will know at the when you reach the expertise level, and that is how that what command it would be. If you do docker build docker file, here you defined cmd npm start. Okay, so cmd npm start and entry point npm start. So what I'm going to do, I'm giving you a homework for that. what you have to do
Okay.
for today, you have to set up Docker at your end, and you have
Mm.
to understand what all these Docker file annotations are. So there's one official.
Okay.
If you type Docker file official, only if you type Docker file official,
Mm.
Docker file reference is there, and you can see here
Okay.
all these commands. So these are all the commands. You just need to go through them, and
Mm.
you need to find out difference between entry point and CMD, which is one of the most important interview question in Docker. They will ask you what is the difference between entry point and CMD. They could ask you the difference between run and CMD. So make sure
Mm.
to learn these, to read about these things in depth. Okay, so I
Okay.
will
That
suggest
was
to go
nice.
through this Docker file documentation. I will share it to you to
Okay.
go through it and understand it. Okay, so
Okay, bro.
brother, like I'm done with the I'm done with the things today for today, and
Mm.
all right.